Hello everyone, thank you for watching my video here. In this video, I'm going to show you how to use Python interface to extract data from Thingsboard. Thingsboard is an Internet of Things platform to be able to be permanently online and waiting for the data push from the local sites, the IoT devices, and then be able to visualize it in a very easy way. So it's very robust in a way that once you create a device, the device can create many different types of properties. For example, when you have weather station, you could have temperature, wind speed, and rainfall. Everything comes up together, and at the same time, you can create another keys properties to say water level or water temperature. So the data looks very dynamic rather than a conventional matrix style. So that's very convenient. The second part for Thingsboard is that the visualization is pretty straightforward, because you could just create a new plot and zoom in the plot to the specific date where the event is taking place. So the visualization is pretty convenient using a web page. But then the issue is that at some stage you need to do the post-analysis. For example, you need to find out a property as a function of all the measurement you've done. For example, you would have actual evaporation. The actual evaporation is actually a function of weather plus soil. So you actually have to integrate all the data all together. And that actually creates a trouble, because weather usually are measured in every 5 minutes, and soil is usually measured every hour or so, depending on how frequently it's being changed. So if you look at that data from a spreadsheet, every single time doesn't align with each other. So that makes the analysis very clumsy. If you are using a spreadsheet, you actually have to find out the property that occurs at the same time, and that's almost impossible to just use spreadsheet. So in this case, Python comes along, and Python has got a pandas, which is panel data, and it's pretty convenient to do the average, maximum, and minimum in the specific period of time, for example, days, or doing very complex time-based analysis. So we are going to make full use of pandas functionality to post-processing the data comes from Thingsboard. So here is the example. So before we move to Python, I really want to show like the existing data we have already got so far. So I could go to my maintaining Thingsboard, and then log it in so that you can see the data. So in here, we need to put in our credentials. And after putting the right thing, you will see the interface. And the thing that we need to look into is literally the dashboards. So we have one object dashboard that's called boiling. So if you look at the raw data, it doesn't come up with anything, because we've already done the experiment a couple of weeks ago. So to be able to visualize the location, we can just simply choose, let's say, next 30 days, and the result needs to be every 2 hours, right? And then we'll be able to see, this is basically data. But the data is actually too sparse, so you are not able to see the result, right? But nevertheless, we can just simply zoom in by hold the left button and then release it, and then you can see a bit more details here. But still, you've literally got 2 points, and we can further improve it by using the advanced way, I think. So then we could try 1 day, and so perhaps time period might help. So we've got that event occurs on 18th of July from 9 o'clock to, let's say, 17 o'clock. So it's 1/7. Oh, hold on. So this one actually needs to change to PM. And this is going to be roughly this range. And then the group interval is going to be something to make sure that it's actually covering, having average, having the specific interval that is that's small enough to cover all the details. So now if we zoom into this area, we'll see an event. And in this event, what was happening was that we have a water boiling experiment. So from this time point, the temperature increases due to the water boiling in the beaker. And then the temperature slowly goes up to 100 degrees and no longer going up anymore. And at that time, the scale reading is decreasing, right, slowly. And during the time, temperature doesn't change much. And later on, we switch off the heat. And so the temperature going down. And because the heat supply is stopped, then you wouldn't be able to see much decrease of the weight measured by the scale. So there are some, this basically shows very clear, but the result doesn't look as good as what we want. For example, there are some false data where the measurement was not correct, so we need to remove it. The second thing is that we don't literally need all the data. We just need really a few things here. So blue one can be removed. The gray one can be removed. The green one could be removed, and the other green one can also be removed. So that's basically the pure data we need to focus on. And we could also further zoom in by hold the left button of the mouse, and then we can see this is the event. And again, because of the zero false reading, we couldn't be able to see the result very clearly. So we can hash the blue line, and then this is basically the weight loss. So we just need to look at this area of data rather than the whole thing. So if we come back to the whole thing, remember the result was not quite looking good. Even say 30 days, it doesn't really come up to the points that we have. So that's basically the thing that we're trying to play with using Python interface. To be able to do that, first of all, we need to download Spider in Windows system. So I've already downloaded that. And Spider is a free software produced and maintained by the community. I find is that as a long-time MATLAB user, I find that the Spider interface is pretty convenient to use, because it provides almost every single functionality that MATLAB graphic user interface is providing. So it's very convenient. Actually, before we do that, we need to download the pyduino interface, the pyduino library. Pyduino library is basically a library that provides software for online data logging system that we produce. So the online monitoring system has got Raspberry Pi and Arduino all together. So the Raspberry Pi is used to provide programming interface, whereas Arduino is to hook up with all the sensors. So the reason we call it as a Pyduino is because that Arduino is using the Arduino C, which is a compiled language. And the compiled language is not quite easy to use, given that every single change needs to upload it to the firmware, and then if you have more data, more sensors coming, you need to compile multiple times. So it's not very convenient. So what we're trying to do is that use Python interface to control Arduino. So in that case, we can just hook up sensors on the go, and then we don't have to upgrade the firmware every single time. But that also means that the Arduino firmware in our library is able to read almost every type of interface, let's say RS432, RS232, or even SDI12. So before we start off using Pyduino, the first thing actually is to download Pyduino. So the way of downloading the Pyduino is to go to GitHub. So if you simply search GitHub, say GitHub Pyduino, I'm just checking whether this comes up. Okay, so basically this one comes already. So that's basically Pyduino. So you've got the website, the web line here, the web link here. At the same time, you could clone and download. So download ZIP. So this is basically ends up with a zipped file. But I'm not suggesting you to use this way, because using this way, if I've got some updates, you literally have to download the zip and unzip again. This is not very convenient. Instead, I would prefer everyone to use Git. So the way of using Git is to use like PowerShell here, right? And you obviously need to have Git well installed. So in here, I could say I create a folder first, say demo, right? And then we cd into demo, right? And then it's an empty directory for sure. And then we can put in git clone with the specific address that we provide here. And then we simply right click the mouse to be able to paste it on the command prompt. Then you start off cloning. So by this way, you basically end up with a library that can always in line with the progress of the development. So I use that on a regular basis. So then after we have installed this, after we download this, the next thing we need to do is to let Python environment to know that there is a library called Pyduino available. And this, you can't take it for granted. You need to let the system know by itself. So the way of doing this is to right click your this PC, properties, and then go to change settings, and just wait for a while. And then you will be able to find out this from the tab Advanced Environmental Variables. So the below here is literally the environmental variables you predefined within your operating system. So this is literally equivalent to using export within Bash RC if you are a Linux user. So the way we do this is to find out Pyduino. I actually had a Pyduino before, but we need to change the new address accordingly. So you would just simply click edit, and then we need to copy basically this directory. So here we need to go to Pyduino, because after the pull, the clone, you end up with a new Pyduino directory under demo folder. And then we paste this here. Oh, sorry, we didn't put the copy here. So I just need to figure out a way to copy it. So I use Ctrl+C, I think that could work. Yes, okay, so basically Ctrl+C would work by copying things from the Windows PowerShell. And then you click OK, it's been changed, and then click OK again. And then, well, the second convenient thing is that we need to reboot Python interface to let the system recognize the new variable you just created. Okay, it's coming up. During the time that it's been loading, I'm just sharing a bit story that that after using Spider for quite a bit time, I do realize that it's pretty convenient to use, and it has given all the information, all the functionality that MATLAB interface is providing. So, given that it's also free, so if you really have a choice of choosing between Python and MATLAB, I believe that Python would be the preferred programming language. This is my personal opinion on this. But I think what type of language you use for your project is predominantly driven by, first, what is the library you need to use. So if it's MATLAB, then you go for MATLAB. If it's Python, you have to use Python. The second thing that will drive this is that what is the language that your team are using. So if your team prefer to build up software using MATLAB, then you should just stick into it, because then it's much easier to communicate. So that's my background opinions about what type of language you use. But for in this case, we prefer to use Python, because pyduino is basically a scripting language and scripting library based on Python. So to start with this, we just have a quick introduction about the background we have it here. So on the left-hand side, it's the script area. So that's where your Python file is displayed. On the right-hand side, you would have particularly the lower side that has got a command prompt. So in the command prompt, you can start off interfacing with the Python, and you could use ls or pwd, which are basic commands that you can use, or you can import numpy as np. This kind of typical thing could be done. One of the things that you do need to be aware of is that the current directory, which is up in here. So the current directory is where you are working on. This could be changed either by clicking from the underneath here, or you could use the file explorer to go to the specific location that you want to go. So we could either do this by Ctrl+C and then go by CD to the specific folder, and then you will see that the address is changed accordingly. Or you could further go there by double click. Say currently it's under pyduino, you could go for Python and then TB to CSV. That's where we are going to go, and then you see it's being changed accordingly. The other interesting thing that I would like to introduce here is that it has got a variable explorer. So this is something that IPython doesn't really have, but it's very handy for the first user. So let's say if I call a variable as a is equal to 4, then you will see that within the list. So we could do another one, say b is equal to 5, and then it comes up, and c is equal to a plus b. You'll also be able to see that from the variable explorer. So it's pretty handy. So come back to the problem now. We do have a TB to CSV back subfolder within the Python directory. So you can go there. And what you will see here is basically 3 files. The first is the get data Python, which is basically the script to do all the things we need to do today. The second has got a schedule JSON. And the third has got a TB credential JSON. So to be able to allow the program running, we first need to copy a file, copy this to its proper name. So I could try this. I'm just trying to figure out whether the Linux command is able to work here. So we basically change the name to TB credential JSON underscore to TB. Okay, CP is not able to be recognized. How about COPY, which is actually available in Windows environment? Yes, that actually works. That's great. But the font, the size is different. Okay, so we open it up. Okay, so we need to first explain what happens here. So TB credential is the file that contains all the critical credential for you to log into the online monitoring system. The reason that we didn't put the original file in here, instead we put an underscore here as a watching file, is because we don't want you to put in your credential in the original file and later on upload it to Thingsboard, upload it to GitHub. Because if you upload to GitHub, your credential will be public to everyone. So here, this underscore file is a template for you to play with. So in this example here, what we need to put in is all the credentials. What is the area that you are going to look into? So basically, to look at the specific time where the experiment takes place, and how many data you want to get from there. So those kind of key information. So the thing we need to change, comments here does not have, it's basically an explanation of all the details in those input. So the second one has got the Thingsboard address. So we need to put this one in Thingsboard, sorry, not Thingsboard, this is actually monitoring, uqgc.org, right? That's the location. And then pyraspberrypi.com, that's basically the username. And then we need to put the password here, which is Raspberry for my case. And the next one is actually keys. So what the key is actually the type of the measurement within your device. So as a weather station, it could be temperature, it could be humidity. And for my case here, they actually have scale 1, remember, back here. Back in the web page here, we've got temperature underscore 1, temperature underscore 2, and here you got scale 1 and scale 2. That's basically the key. In my case here, I just want to download everything, so you can simply just put all as the input argument. The next one is actually underscore keys comments. So this is the just the explanation of what keys is doing, and it doesn't actually change your result. Start TS, this is a critical thing. So start TS is that instead of extract all the data within the device, you just need to get the data from a specific time. So the format is going to be written in this way. So it's year, month, date, hours in 24-hour format, and the minutes. And if you leave it as empty, that means you started literally from epoch time, which is 1970 January of the 1st, right? I tend to use the underscore start TS as a way to comment in the JSON file. So by doing this, we know that this specific argument is not going to be parsed, but nevertheless, you can just leave it there for you to use easily. So in my case, what we could do is basically use backspace here, and then start TS from there. Then you basically change the starting time to here rather than the epoch time, right? So the NTS has got the same thing here. So this one is not going to be functional because of the underscore at the very beginning. But the NTS in the here is going to be functional, be parsed. So we know that this experiment actually started, completed at 20:00, which is 8 p.m. in the afternoon. The interval here is basically how often you want to extract the data. So let's say if the program has found out there are 20 points to be extracted you just want to get 10. In that case, you can put interval to 2. The limit here is that how many data you want to get in total. So that's also a kind of constraining factor. So in our case, we can just try to leave it as empty, which means that all the data within the region will be extracted. So everything started with a underscore actually means it's a comment, so you can just leave as it is or just simply delete it. That's not really an issue. The only thing you really need to be careful about the JSON file is that the way to separate between each argument is the comma, but for the very last input, it doesn't end up with a comma. So if you put a comma here, it's not going to be parsed properly. And of course, everything needs to be enclosed by a curved bracket. So the final thing here is actually the device ID. So remember now, we've got the address to go, and we've got the credentials. And then the question is that what device you're going to use. So one user could have multiple devices. So in my case, I only have one device here, but you could have multiple devices. So you need to find out the specific tag to single out the device that you are going to visit. So the device ID is basically that specific tag, and that could be found by copy device ID here. So that's basically the way how you are going to differentiate or single out the specific device you want to get the data from. So if you look at the my clipboard, you find that the string is exactly the same as the device ID. I put it as a default. So to make it happen, then we need to remove all the details. Now we save it. So there it comes with a star. The star actually means that it's unsaved. So to be able to make everything functional, then we need to use the TB credential saved properly. After that, we are ready to use the get data Python here. Now, I think what we can do here is to first run the script one by one. And then I'll come back to explain why this specific line is there. So the first 20 lines here is to import and load all the associated libraries. So to run the script, you could simply copy the whole thing and then paste it to the command prompt, and then multiple enter is granted to execute all the lines. So one thing you might be aware of is that we do have a bunch of things in between here. Instead of just use import, we actually use import reload and sys append. So why do I need to do that? This is actually the way for me to debug any debug the program if it's necessary. So by doing this, whenever I change the library a tiny little bit and then rerun the script, the change will automatically be loaded to the new script. So it's pretty convenient for me to use, but I think as a user, you simply just use import Thingsboard to pandas, and then you will be able to import the library in the proper way. So nevertheless, those are all being loaded successfully, which is great. The next one is basically create the TB pandas based on the TB credential file, which was here. Then the way of loading it is simply copy and paste that specific line. And then now if you go to the variable, this variable is not actually here, but you can still use TB pandas here to see what's inside. So if you go to TB pandas input JSON, then you will be able to see all the details we have here. So remember we have the time start TS, password, and Thingsboard address and username, this sort of thing. So it's already been loaded properly. Now, these are the critical methods that you need to go through by using the Thingsboard to Pandas library. The first is to get token. So the way of running it is simply copy and paste the whole thing, and you wouldn't be able to see anything coming out of this. So what does this specific line do? So after you log into the Thingsboard, you will extract the data not by the password itself, but instead you are going to use what we call a token. The token is exactly the same as a user and password, but it's written in a very, very long string. So to be able to expose the token we get so far, we can again use the input JSON, and you'll be able to see that it creates an argument called TB token, and that ends up with this much of line. So this line, this information is exactly the same. It is equivalent to your username and password. But the interesting part for the token in Thingsboard particular is that it expires every 15 minutes. So once you have created a new token, you really have to use it immediately to make sure that you are able to get the data. So that's the reason why you obviously need to refresh your token if you find that you are about to expire. Now you've got the token, then you will be able to get all the data available within the web page or within the Thingsboard. To start with this, what we can do is basically to get keys. So remember that we use keys all to tell that now we need to get all the keys, which could be temperature, property, temperature, humidity, or if it's in our case, it's actually all those arguments in the dashboard, boarding experiment example. So those ones. So we need to have a list of this. So to be able to do that, we literally copy this section and paste it to here, and nothing comes up. But if you just simply go to input JSON, you'll be able to see that the list of keys is given here. So that has got humidity scale 1, 2, 3, temperature 3. So that means that we got the proper update from the server, right? Now it's the time for us to get the data. So that could simply be done by clicking, putting in this specific command. So it ends up with something. It's a little bit slow, but it ends up with successful because it doesn't end up with anything wrong. There's no error comes up. So to be able to check all the data, what we can do is to go to TB pandas result JSON, and after you do the click, you find that the data is quite a lot, right? And it's very difficult to see the structure of the data directly from the command interface. So what we can do here is that first list all the data and see what is the next hierarchy, the top hierarchy out of this. And you will see that this is actually all the keys we have. And if we want to go to the specific data, what we can do is to use the result JSON and then single out the specific result that you want to visualize. So that's the data. So how many of them? It's quite a lot, right? So it's roughly, let's say 200 or something, right? And if you look at the data structure, it's actually JSON file, right? And also it hasn't yet digitalized, which means that it's not a floating number. It's actually a string stored, which is symbolized as the U immediately before a quote, right? And if you look at the structure, what does it look like? It's actually TS in epoch time and in milliseconds and the values, right? So the next step for us is actually convert this to something that we can play with, which is like pandas, right? So we need to convert those specific tab, these let's say JSON tabs, into something that we can plot rather than those values. The way of doing so is pretty straightforward. You just need to run that. Say TB pandas convert data to DF, and we literally paste the whole thing to the end of the command line, and then it tells you that the progress, which is to convert all those ones, and then we'll be able to look at the result. And so the result is going to be result DF. DF is data frame, is short for data frame. Then you'll be able to see all the data is being visualized properly. And to be able to see a bit more here, I'm not sure how we can basically expand that, but what you can see is that it ends up with, again, a few panel data. So we could also use the list to tell you the highest level of tabs. So as you can see here, TB pandas has got all the keys, and the keys has been successfully converted into different panel data here. And for each panel data, we will have all the specific time where the data is being recorded and also the specific value, right? If you want to visualize the data, the way of doing that is to use the underneath function below. So you could say plot the scale 1 and scale 2. And then you'll be able to see the result like that. Remember, we just had that before. So one scale has got some false data here, and the second scale was monotonically decreasing, which is fantastic. So now we've already got the data in pandas, and that's fantastic. But it comes with a few new things that we need to figure out. The first thing is that those pandas have their own timeline, and those timeline doesn't has the same number of rows. So let's say, again, if the scale is measured every 10 seconds and the temperature is measured every 5 seconds, so the total number of data within each panel data is not the same, right? The second thing is that if you want to remove some of the values, and that means you can't really use the data here to write a function. Let's say if you can simply remove this amount of data, but I want to calculate what is the result of A plus B. And if you try to use a specific time in here and then you find there's no data, and obviously you wouldn't be able to find out a result that is the result of A plus B, and that makes post analysis very, very difficult. I think what we really want to get at the end of the day is like a panel data, which is like a CSV file. So it has got m rows and n columns, and if you want to just all the data is basically within one timeline. So in that case, if you want to calculate, let's say the add up of scale 1 and scale 2, you simply just add another column and say the result is going to be scale 1 plus scale 2. It's pretty much like use Excel, so to create another column, so it's pretty straightforward. But the current outcome doesn't allow you to do so, right? So we need to find out a way to do it. So before we start off making the large panel data, we first need to filter all the data that we don't want. So for example, here we've already identified that the scale 0 here, scale 1 here has got a few 0 points, and the way of removing it is to use the underneath mechanism we produced. So let's say if we look at what this line is doing, is that if TB pandas result DF scale 1, the values is less than 5, just treat it as not a number. So this tiny little thing here is basically like a masking matrix which expose all the problematic data, and then we just name that specific data into NP not a number. So we can give it a try by doing this, and that's been successful. And then we could just run the second command again. What you will see now is that all the data that being wrongly measured is becoming not a number, and because of the not number, once you're plotting it, they will not come with a continuous line. And so data looks beautiful, that's fantastic, but again the problem is that if I want to look at a result of scale 1 plus scale 2, you wouldn't be able to get that because the data here is not available. And the second complexity is that real is that maybe the specific time you have it here, but you may not have a data there. So their timeline might be different. So that's the problem we are going to solve. The way of solving it is to create another panel data. And to create that empty panel data, we need to have a second JSON file. That is the schedule JSON, right? So in the schedule JSON.json file, you've got the project name. You could name the project for anything that you like. And now you've got the start time and end time. So this start time and end time is hopefully being within the section you get from the web page. So currently we have here starting from 3 p.m. in the afternoon to 8 p.m. in the afternoon. So preferentially you could do that by increase this a little bit a bit later as compared to the other starting time. The reason we have to do this is that this data will be interpolated. If the timeline within the schedule JSON is longer than the original data, that means we need to do an extrapolation. And usually extrapolation is basically the linear expansion beyond the time that the data is not available, and that will not end up with a very good looking data anyway. So you always try to make this timeline within the timeline that is defined in TB_credential, and that's basically the trick. So currently it's well within, it's fair enough. Underneath here we've got the delta time second, so we basically say that you want to get the result every 60 seconds, which is 1 minute, right? We save it again, and we go back to here. Then the next line is going to be read all the schedule files. Right, so we do that. And that creates an object called SP input. So you see all the information we have in the schedule JSON is already here. The next is to compile the other two useful things that we use in pyduino. So that's panda scale and constant, right? So that two specific object has been loading, and then it's the time for us to do the interpolations. So the first line here, SPSH, is to create an empty dictionary. The second is to plot interpolate false. So the plot interpolate is that after the interpolation against the raw data, plot the result straight away and make a comparison, right? So as an example here, I want to make it as true for now, and later on I'll show you what will happen if you choose that for false. So if we do that to true, and then we go further down here, so that's actually to create the object based on the information given from the schedule JSON. So we can paste it in. and the SPSCH will be able to get one thing called the DF, right? And the DF has got the timeline well set up. So daytime starting from 5:01, and time days is basically the days since the start of the first timeline, right? So we've got the initial headers of all the all the keys that we want to interpolate, and then it's a matter of adding up the extra data. The way of doing so is to use the following commands. Of course, that we need to define the start DT and the end DT properly, and after that it's to merge the data. So merge data, we want to give the scale 1 as a first trial. So to look at the format, what does this do basically? So SPSH has got a method called merge data from Thingsboard, and the input time series is basically what is the input time. So in our case, remember, we've already got the TB pandas result DF and with a specific time of scale 1 index. We could even try to put this one into the command prompt, and then you'll be able to see that this is basically the original time, that timeline of the raw data. And the second argument we will have is the input data series. And the input data series here has got where the data is located. So clearly it's going to be scale 1 value tab. Now, where you want to get the new data out. So that's actually given here. So you need to give the new the time series based on the current index, which is shown by the previous SPHDF. You see the daytime, which is well aligned, which is only at every minute, right? So that's your new timeline. And then after that, it will produce the interpolate result. And sometimes you really want to change the name. You say, okay, in the new spreadsheet or in the new panel data, you want to change the name differently. And this sometimes is needed because it would, if you try to merge from different devices and all different devices ends up with different tab names, then you want to differentiate them. So in our case here, we don't want to rename that, so we can just still put it as scale 1. And after that, we've got the plot interpolate. That means that do you want to see the plot result? We just said yes. The coefficient here, this is a critical parameter for us to do the interpolation. Basically tells you that how smooth your result want to be. And usually the rule of thumb is that if the number becomes smaller, the result becomes smoother. Whereas if the value becomes bigger, the result will become much more to the detail. And we can try to test that by changing this value here. The final argument here is RM num. So that actually means that if you've got not a number, you just simply ignore it, right? So that's actually our case. So the way of doing that is simply copy the lines and then paste it to the command prompt. And after some processing, then you will be able to see the result. So from this result, what you will see clearly is that the scale goes down well, it is supposed to go down monotonically, but if you examine the data, it wasn't the case. For example, here it doesn't looking like that. So usually, doing the experiment, you would expect some kind of fluctuations. Let's say someone just by mistakenly touching the scale. So some of the data really is kind of oscillation that you don't want to put into the system. So in this case, the best way is to put the interpolation data the interpolation parameter is relatively small. So here we've got 5 power negative 5. So if we want to try to make that relatively smaller, let's say 8, right? Then you will be able to see that the result becomes much smoother as compared to the original data. So the difference is quite clear. So after you increase the specific coefficient, the data looks much smaller as compared to the continuous result, as compared to the small, to the relatively large coefficient here. So that is actually the way for you to remove some of the data that appears not quite right because of the temperature oscillations or any other oscillations induced by any kind of thing. The second interesting thing really is that, remember, in the example here, we have some false data, which the measurement was 0. We first remove those data back to not a number, and after the interpolation, those gaps are properly being filled in, right? So we can zoom in by click this button here, and then see all the data has been properly filled in, and that's fantastic, because later on, if you want to make find out a scale 1 plus scale 2, you can still use this data here. And the other useful thing is that you actually know this is what will happen during the gap. So using the interpolation, it makes the data more like a specific spreadsheet later on. Now, we can just minimize that and then try to do all of them. So that could simply done by the second thing is that in this case, if I just run everything all together, it will end up with multiple graphs, and I don't want that to happen. And then I can simply switch off the plot interpolate here. And if that's been done here, then I can simply copy and paste the whole section here. I actually need multiple enter here, so now it's already there. And after all the interpolation, what you will expect from the SPSCH here is that the DF has got a lot more tabs readily to be analyzed. So it's got scale 1 and everything, right? So everything is pretty much ready, and it's actually a very uniform m times n matrix for us to do any analysis if we want to. So we also have got a small plotting functions underneath to plot all the results. So here is got the plotting areas, and then in this plotting area we've got 2 subplot, which is named as AX0 and AX1 here. And we can just put it in. And by default here, I switch off the figure pop out by using the top command here, PLTIOFF. But you can switch down so that if you run the plot figure, you will have a figure pop out. But that wasn't the case for me for now. So we basically plot those data here. And it ends up with all the plottings. So if you want to show the data right now, we can just use this tiny line here, and you'll be able to see the beautiful data here out. So temperature going up and further going down, and the scale is going up and going down. And because we've already filled the gap where the wrong data is being stitched all together, we could simply say that, let's say, we can create a new column by, say, SPSCHDF scale plus, right, is equal to scale 1 and scale 2. And scale 2. And then that will create another column within the SPHDF, which is shown here, right? And if you really want to plot that as well, then you simply do another plot. So we could use, this is basically to plot the scale difference as compared to the original result. So we could just hatch that for now. And we would have that. And later on we've got, remember, the scale plus, right? And then simply run the whole command again. And also we want to the plot show as well. What is that? Why this one is here? Oh, that's the history, sorry. So if I further click this, then you will be able to see all the original data. So remember, these are the original two plots, and then that is actually the scale plus. So that's basically if you want to plot that from the Python interface. Again, if you're happy with using Excel, what you could do is that simply use the tiny command underneath here. Then you will be able to see that in the same directory, you create a result CSV file. And to be able to visualize that file using Excel, you could go to the folder, double click the result CSV, and you will be able to see a scale file that has got all the data, including new one that we created, at exactly the right time, and every single timeline you got all the data, even though their original timeline would be different. And the number is quite uniform, and then you can simply do things on top of that. So basically, this is all the materials that we want to show, which is to use the Python interface to extract the data from Thingsboard and then interpolate all the data to end up with a spreadsheet or panel data, so that the data looks quite uniform to be able to manipulate and then tell your story. Hope this video is very helpful, is useful for you. Thank you very much.